You had to change that sound. Especially in today's world, that stuff happens, right? I mean, you wouldn't expect it to happen at a Christian school. You never know, right? I mean, crazies everywhere, so it just seems like a very poor sound for like the start of a recording. Okay. So we did our conversion stuff last time, and we kind of saw there's two different patterns, right? But those patterns are consistent throughout any base. So if we're going from something to base 10, we do the ones place, if I'm doing like an octal to base 10, I do the ones, the eights, the 64, so on and so forth place, and I add everything up. The other pattern is if I'm going from the tens, base 10 to any other base, I do the divide by the base over and over and over again and record the remainder, right? Those are our two separate patterns that we have. And we'll actually end up writing a program that does that once we get a little farther into the semester and we actually have some programming skills under our belt. That's not assignment one, is what I'm getting at. But we will write some code to kind of recognize that pattern, that converting between bases is identical regardless of what base we're going to. That small little caveat that we talked about last time we were doing the hexadecimal thing is that we got to do some conversion stuff or mapping to letters when we start hitting 10s and 11s and 12s, because those aren't single for hexadecimal, those aren't single hextits. So hextits are 0 to 9 and A through F, although I will never ask you on an exam. It's always they're always digits. For humans, they're digits, no matter what we're talking about, but they all have to be single characters long, so that's why we can only go up to base 37 using the American alphabet. And if we ever really had a need for something bigger than that, I kind of recall at the end of class last time, and I'm a little out of it today, I'm on some stuff, so if I start getting loopy, just laugh, it's fine. But I recall, I think I asked a question near the end of class, like, why did we need larger numbers? I think you had a paper. Did you have a paper on that?
Yes. When do we use
binary versus octal versus hexadecimal? Okay, what do we find out about that?
Well, binary is computer language, so we don't usually use it that often, but it's best for them to read.
Okay.
Octal is more condensed form, so it's easier for us.
Okay.
And I found something about bit twiddling.
Bit twiddling?
Yeah.
Okay. That sounds like a Miley Cyrus thing.
Yeah.
That's Miley Cyrus is a person, right? I got the names right? I haven't put two wrong names together. What's that?
Debatable.
Well, right, but I got the names right. Like that's a first and a last name of the same person, right? All right. All right. So what about hex?
And hex was even simpler than that. It was easier to do bytes because a byte is 8 digits in binary, and hexadecimal puts everything into 4s. So you just use 2 hexadecimal.
Right, two hexadecimal to represent what would be equivalent to an 8-bit number. Okay, fair enough. So based on that, what would you say is the advantage? So I'll ask it a little bit more generically then. What is the advantage of a higher base number? Like, what's the advantage of base 16 versus like base 8 or base 3? I want to steer clear of just saying base 2 because computers like that. I get it. Computers like base 2 because you got the on and off, the digital logic stuff, and at the end of the day, they have to represent stuff that way. And when you take the computer organization class, that'll make a whole lot of sense to you. But generally speaking, what's a larger base good for? Go ahead. Yeah, you kind of alluded to that as well. So representing what we would call a big number in a compressed format. All right, so I've kind of mentioned a couple of times that, if we ever need a value bigger than base 16, or, really the issue for us is going to be if we need a value bigger than base 37, then we got to start exploring new alphabets, right? We can come up with our made-up thing. I think I joked last time about Klingon or something like that, but there's actually, first of all, somebody's made the language. It's a thing. It's a nerdy thing, so does anybody in here actually know Klingon? Klingon. Oh. Star Trek? The show Star Trek?
Yeah.
You know of the show?
Yeah.
Okay, yeah. One of the alien races in Star Trek is called the Klingons. And it's there's a cult following to the show, and people speak Klingon. they made the symbols and everything, and Big Bang Theory.
The alien thing.
Huh?
It's like Futurama, the alien like letters and stuff.
Yeah. Symbols and runes and that kind of stuff. Yeah.
I remember a clip of Big Bang that actually spoke Klingon.
Yeah, they do. Yeah, they make fun of it in Big Bang Theory. Although generally, I mean, the reason I asked does anybody in here speak Klingon is generally that's you figure that's kind of a nerd thing, right? And I mean, I know I look cool, but in real life, I'm like super geek. Like I did the whole tabletop role playing stuff, and I used to be like a dungeon master at the conferences. Yeah. Back in the day when that was cool. Now it's less cool to do that, But point is that I figure if anybody was going to speak Klingon, it might be me, but I don't. So I don't know if that's a good thing or something I should be embarrassed about. But so nobody in here speaks Klingon or wants to admit to it. But we did look it up. I think it was last semester or last year or the year before that. At some point when I was giving this similar lesson, the Klingon alphabet actually I think only has 22 symbols. So that doesn't help. we lose some the ability to represent even the numbers we can do out of the American alphabet. And I think somebody last time said, oh, well, can't we use lower and uppercase letters? Problem with that is kind of our standard. I think the official designation for hexadecimal is using the uppercase symbols, yet pretty commonly when it's written in lowercase. So that ship has sailed. We're interchangeably using those numbers. So, and that's again more trivia knowledge. You're never going to lose points if you use the wrong case. In fact, I'm only about, let's call it 97% certain that the uppercase letters are like the actual standard, but whatever. They are definitely used interchangeably. Okay, so now with that in mind, under what circumstances do we really need to represent really large values inside of our computers? What we would call large values. Like not the value 7 or the value 242, numbers in the millions and billions. Those start becoming what we would represent as big numbers, right? At what point do we need to represent that kind of stuff inside of our computers? I think I've referenced it a little bit at this point.
Within the memory.
Okay, why?
Because there's a different memory address for each thing.
Okay, so we have a zillion memory addresses. I probably talked about how our memory in our computer, like an address in real life is way more complex than a computer address. It just looks less intimidating to us, right? Because we're used to dealing with real life addresses. So in our computer, we think of basically there's only one street in existence, and it's got a zillion houses on it. So you have house 0, house 1, house 2, house 3, house zillion. All right, so we need really big numbers to index all of those houses. Right. So when are we going to need larger numbers? Well, when our memory gets even larger, and we can take it away from really when I say memory, it could be almost any kind of storage. So what's typically a large amount of system memory in our computers today? If you buy a new laptop today, the starting point, if you really go budget pleaser, is maybe 4 gigabytes, but most laptops have 8 gigabytes of RAM in it. You can go 16. There's probably a couple of brands, just maybe like Alienware's, maybe that you can bump it up to 32 gigs. But that's kind of our top right now on laptops. But 16 is probably considered kind of pro level right now in laptops. Desktops, 32 is maybe more common than it would be in a laptop. But even then, when you get a new desktop computer today, maybe 16 gigabytes is somewhat standard. 8's probably your starting point. But that's kind of where we're at, right, in terms of gigabytes. But what about hard drives? Do you figure that probably when we're, you'll learn about this in the operating systems class, but when we're writing stuff to our hard drives in our computer, that it's probably somewhat similar to how we address our system memory? We have a whole bunch of buckets in our hard drive. It's like that big street, except the street's even longer. Speed limit's slower. Okay, so system memory is considered to be pretty fast. So that's our, 70-mile-an-hour speed limit. Those are our freeways. All right, so you got to pull into those driveways quick to get out of the way. But hard drives, a little bit, they're slower. It's like the 35-mile-an-hour residential area type thing. Not as high performance, but our hard drives are bigger than our system RAM, right? So when you get a new computer today, what's your standard hard drive size in a desktop computer? Probably at least 1 terabyte. Okay, how big's a terabyte? Did we just say it's big? So, who?
1,000?
Oh, close. Well, no, 1,000 is like very close. 1,000 gigabytes, but it's not quite
24.
1,024 gigabytes. So let's look at that here. Go right after, just so we can put those things in perspective. Because another thing I like doing, and it's very related to what we deal with here, because when we're talking about memory, we're indexing some size of things inside of our computer. I also like to demystify consumers, or I guess consumer misinformation. So let's use this as an example. So we're going to do memory sizes. I'm going to create 2 separate little sides to this because we have bits and we have bytes, which is the confusing thing. So we have a bit, which is a 0 or a 1. And then we have a byte, which is 8 bits. Then we have a kilobyte, lowercase b. This is 1,020, or kilobit, lowercase b. This is 1,024 bits. We have a megabit, lowercase b. This is 1,024 kilobits. We have a gigabit, lowercase b. This is 1,024 megabits. We have a terabit, which is rarely used but exists. This is 1,024 gigabits. On the other side of things here, we have a kilobyte, big B. This is 1,024 bytes. We have a megabyte, which is 1,024 kilobytes. We have a gigabyte, which is 1,024 megabytes. We have a terabyte, which is 1,024 gigabytes. Anybody know what comes after terabyte? Oh, we can keep going in the number system. You can't buy one now. Go ahead.
Is it petabyte?
Petabyte? Then what?
Yottabyte?
I think it's exabyte.
Exabyte.
Yeah, exabyte. Yep. But we're not quite there yet. I think that's really what you're saying. Is in terms of the hard drives you're buying today, the biggest ones are measured in terabytes, right? You go out and buy a hard drive. I think one company right now is in terms of a single drive. I think, is there a 6 terabyte one now? I know there's definitely 4s. But we're kind of in that ballpark, right? 4 to 6 terabytes. You can actually get some cluster machines that are effectively like a machine that has like 4 hard drives in it. So you can get like a 16 terabyte array. But there's physically 4 separate drives in there that are mapped together using something called a RAID. Not important in here. You talk about that in 175 at some point. But punchline is these are how things are broken down in sizes. Now, what's interesting for us is across these 2 columns, things often get used interchangeably. So, for instance, most of us have internet at home, right? What speed internet do we have? It's going to be very interesting the way I hear you describe it. First of all, as technology majors, we should all know about the technology we're surrounded with, right? So what speed internet do we have? I'm guessing most of you do not know. We're going to call that problematic, but go ahead.
I'm going to guess 13 gigabits per second.
Oh man, you would love 13 gigabits per second. you don't have 13 gigabits per second. I don't even care who your provider is. That's not what you got.
1 gigabit?
1 gigabit per second. It is possible, depending on where you're from, but that's kind of your max. Where do you live? Milwaukee. AT&T is actually supposed to bring in their 1 gigabit this coming summer, so maybe soon. Not quite. 24 megabits. Okay, first of all, the thing that's plausible. That's hold on. Oh my, I was about to like compliment you. Now all of a sudden you started getting rocky on it. You said megabits. You said 24 megabits.
Right.
That's actually correct. Yeah, 24 megabits. That's in the ballpark of reality, especially if you have like a cable modem, Time Warner or something like that. If you have a DSL, they're usually slower than that. But yeah, they're measured in megabits. And we're just starting to tiptoe into the realm of gigabits now, or a single gigabit. Now, what's interesting there is you've probably heard people refer to your internet speed as, oh, I have 20 meg internet or 30 meg internet. Kind of leaves the little room for interpretation, exactly. So if we're going by your number, 24 megabit. So this is 24 megabit per second, small b. What's the fastest you can download something? And when you walked in today, many of you probably would have said, oh, well, 24 megabytes a second. Megabytes is big B. Bits is little b. Slower. Now, when we looked at this, everything over on this side is a scale of 8, right? So to get 24 megabits per second into megabytes, we divide it by 4, and 24, or divide it by 8. 24 divided by 8 is 4, right? So this is actually 4 megabytes per second maximum download speed. Now your upload speed on consumer internet is almost always slower than your download speed. So you might have 24 megabits down by, maybe something like 5 megabits per second up, because your upload speed is somebody else's download speed. So when you use your upload speed on your internet at home, you're using it for like attaching things to your emails or making it. It's a who? That depends. Yeah. I mean, like for instance, at home I have 200 megabits per second. Oh, I got you. I did bad math. I got it. I was testing you. You passed. All right, so 200 megabits per second. What I have at home is 200 megabits per second by 17 megabits per second. And that's Time Warner. But, in any case, I'll fix that again. In any case, this is called an asynchronous internet connection, and almost all consumer internet connections are asynchronous, meaning your upload and download speeds are different speeds. It's almost always that your download speed is faster than your upload speed. Because as consumers, we're primarily using our upload for attaching things to emails. That's the heavy use for our upload. That's our intended heavy use for our upload. Your typical use for your upload is going to be doing little requests like, going to google.com, which is a little tiny packet of information. Doesn't take up very much. That's going to be less time than it takes to blink for that to get sent over your 5 megabit per second connection for your upload. Now, why do you think they make your upload so much slower? Go ahead. Go ahead. Yeah, go ahead.
What is ping?
Ping. Okay. Ping is something called, it's latency. So ping. So you're talking about it from a gamer, right? So this is something called it's latency. This is the amount of time for a request to make a round trip to the server and back. So if you're playing a real-time game, first-person shooters, those types of things, every time you're moving on the screen, your position needs to update the server because everybody else needs to get updated, right? So you actually see dudes moving around. And if your ping or your latency is crap, so like for instance, a 3000 ping is 3 seconds, okay? That means every 3 seconds your position is updating. And usually a lot of first-person shooters will kick you out if you have ping that's bad. It becomes unplayable, right? You're dead before you know you're dead, is kind of the idea. So that's ping, and that actually leads us into another question: is what is good internet? All right, but before we get to that, let's go back to the question. Why do you think our common internet connections today, the download speed is so much faster than your upload speed? Okay. They're capable of synchronous connections. In fact, when you have a business address and Time Warner Cable makes you get business cable, a lot of times those are synchronous connections, which means the upload and download speeds are the same. So it's not really a limitation of the cables themselves, although there's going to be a maximum speed that is a limitation. So for instance, over I'm trying to recall what the actual maximum speed over coaxial is, but now a lot of the cable companies are starting to do fiber directly to the house, so this is going to become blurred, but it's probably somewhere in the 500 or 600 megabits per second. But we're starting to jump that now that we're having fiber go, but that's not the reason for the asynchronous. What do you think? Go ahead.
Is it because with upload speed you have to actually write data to a server somewhere instead of just grabbing it and setting it down the line? So in theory, with downloads, you could have 10 different people downloading the same thing. So there's only really one pull request and send it 8 different ways versus one way and going.
Well, something I mentioned a few minutes ago, just kind of in passing, is that your upload speed is somebody else's download speed. Which means that if you're running a server out of your house, you're serving a whole bunch of your favorite ripped DVD movies or something, I'm guessing. That means people could download it from you, right? And more than likely, your internet service provider doesn't want you running servers out of your house. Okay, so this was the original reason for it, but we've actually found workarounds for this. I'm sure none of you have participated in any of these workarounds like BitTorrent, right? But what does BitTorrent do? Anybody have a theory? I know you've never used it.
General use speed.
So BitTorrent says, well, okay, no single source can give me an upload speed, which would be my download speed. So if I'm downloading something off his internet connection, I'm not getting it at 24 megabits per second. I'm getting it at 5. Even though I can handle up to 24, he's not able to push it to me at 24. So with that, I guess it was your internet. He had crazy gigabit internet, apparently. He just made up internet. Which is actually, you're a big-time gamer. It's pretty embarrassing. You should feel ashamed. It's a public shaming in class. But your upload speed is going to be my download speed as I'm trying to download that. And 5 megabits per second, you divide that by 8, I'm getting that at 625K per second. Not horrible, but in fact, once upon a time, that would have made people drool. But by today's standards, that's not a real fast download, correct? So although it might be really fast on campus sometimes. Campus tends to be either something will take a month to download or something will take a half a second to download. It's very rarely just in the middle, right? It's either really fast or unusable, and that's part of that is on campus we have something called QoS, which is quality of service. So we try to keep what we would call, what the network administrators would call the required internet resources working, while the non-required things like video games and stuff like that would be lower priority, that kind of stuff. So when the internet's flaky, you probably have a better chance at Googling stuff than you have at playing Xbox Live. That might not always be the case, but that's the design. Okay, so the idea is your internet service providers don't want you running servers. So what have we done as a workaround as consumers? Well, we said, well, he can't serve me the file very fast. I'm not going to be happy. But if all of you all had that file and you were all serving me parts of that file, I have 24 megabits per second to work with. I can download some of it from you and some of it from you and some of it from you, only taking up a little bit of your upload speed and a little bit of your upload speed and a little bit of your upload speed. But across the board, I can almost maximize my download speed. That makes sense? And what does BitTorrent do? BitTorrent, they, even though it seems like you could set it pretty low, but they reward those who are willing to upload more with faster download. That's the setup for the system. But usually when you are, obviously not that I know anything about this either. This is all speculating, of course. When you're downloading something, you want to look for something that has a lot of seeds, right? Something that there's a lot of people participating in this particular file. Therefore, in terms of a percentage, you don't have to upload that fast in order to be a major participant in the overall. If you have thousands of people seeding a file, then you're playing your part. You can usually get the file pretty quickly. And then most of us are jerks, right? So as soon as it's done downloading, we cancel it. So we don't want to help. That's somebody else's problem, right? Plus, the longer we're helping, the more suspicious we're going to look to our internet service provider. We don't want to get caught, right? We're ethical human beings. We're only going to break the law for very short periods of time. Okay, you'll talk about this in the ethical computing class. It's very interesting because I'm guessing that most of us in here at some point, whether it was accidental or not, have probably downloaded something of questionable legality off the internet, right? But most of us probably would not walk into Target and pocket a DVD. I mean, right? Even though it's really kind of the same thing.
Still leave a copy.
Huh?
It's still a copy.
Well, but I mean, it's still kind of the same.
With the original one.
Yeah, actually, this could be the even more unethical thing. You go into Target, you steal it, take it home, rip it, and then return it without a receipt. Hey, it's the holiday season. You don't need a receipt. See, now he's thinking about it. He's like, go ahead.
So is that illegal is it illegal because of the method they're using? Like have multiple people
No.
Well, no, it would be the content. It would be the content. I mean, for instance, there's a plenty of legitimate uses of BitTorrent. For instance, many video game patches now use BitTorrent. I mean, it's a good technology for that because now your game providers, Blizzard or whoever, BioWare, whatever, whoever's making your video games, when they push out an update, they have thousands and thousands of users of that video game. If all those thousands of users are hitting one single server to download that patch, that I don't care how much bandwidth they have, they're going to get overwhelmed, right? So if they can spread the wealth so that everybody's participating in distributing the patch, that's good. And those are completely, BitTorrent in and of itself is not illegal. It's just commonly used for acquiring things that are questionable, right? And then there's all sorts of questions of who's actually breaking the law. Is it the person who's distributing it? Or, I mean, if I download it and I don't copy it and I don't give it to anybody else, I just watch it, especially like, for instance, how I rationalize it sometimes, which probably is, I'm sure it's still a gray area. And I pay for cable, so I have all these shows. Let's say you miss an episode of a show or your DVR doesn't record it or something like that. I paid for this content. Go and find it online real quick. 'Cause you can't watch the shows out of order for a lot of these things. You go and find it online, you grab it, you watch it, and then you delete it. I'm not redistributing it on the web, but even then, I mean, I paid for the content from Uverse, not from random person on the internet. It becomes a gray area. And a student several years ago mentioned something here, and I think Dr. Locklear uses a pretty similar saying, and it rings true to me, even though I don't necessarily always follow it, but that technology amplifies what's in your heart, something along those lines, where like I said, most of us wouldn't go into Target and steal a DVD, but we're a little bit looser with our ethics when it comes to things where we think we probably won't get caught, or who's this really harming, something like that. But we could obviously spend a whole course on talking about computing ethics. But from our perspective in here, when we're really trying to understand the concept of memory and what a memory footprint is and things like that, it's good enough to understand that the reason behind having asynchronous internet connections is your internet providers don't want you running servers. Okay, we have a workaround with it now, but even then, you're not going to be maximizing your 5 megabits per second connection most of the time. And even if you are, you're kind of only hurting yourself, because now attaching images and making your Google requests are going to be real sluggish because you're uploading stuff constantly on BitTorrent. Okay, but like I said, most of us are jerks anyway. So as soon as we're done getting our illegal content, we shut that off, because why do we share our? We'll take, but we never give. How many of you did I just describe your exact MO when you're most of us, right? All right, so now I get down to this question: what is good internet?
Depends on what you're doing.
That's a good answer. Let's see if keep rolling with it. I mean, you didn't even know that what kind of internet you had, so I mean, my expectations are low, is what I'm saying. So.
So if you're trying to watch HD video, you certainly need somewhere in the megabit range of download speed. So if your internet suddenly throttles down to 200 kilobits per second, you're not going to be watching anything anytime soon. However, at 200 kilobits per second, you can still generally surf text-based web pages.
Fair enough.
Just fine.
I mean, for the record, if you're at home and you're consistently getting 200 kilobits per second, you need to call your provider. I mean, that's bad by today's standards. Yeah, but also understand, and we used this example a few minutes ago. If you're downloading a file from someplace and you're not getting the speed you expect, that doesn't mean your internet's broken. It means it potentially can mean that whoever you're downloading from can't serve it to you that quickly. If I'm downloading a file from him, I'm getting it at 5 megabits per second max. Okay, that's if he's not sharing stuff with other people and he doesn't have it throttled or something. Now, if I'm downloading something from Apple, who has a bigger budget than you have, right? Chances are, and Apple's releasing software updates, and they don't do it with BitTorrent. Apple just has server farms and stuff. So the point is that if I'm getting stuff from Apple, my expectation is, if anybody can come close to maximizing my download speed, it might be something like an Apple or a Google or something like that. That would be an expectation, but that doesn't mean they would necessarily be able to maximize it. But I should be getting a better download speed from a place like Apple than I should get off of him. All right. But even then, if you're downloading a patch to your operating system from Apple or from Microsoft, although I think Microsoft uses BitTorrent now for delivering their patches. But regardless, even on a great day, you're probably not getting that 3 megabytes per second. We feel pretty good if you're downloading a patch to something. If you're getting 1 megabyte per second, I would say that you shouldn't be really complaining. 1 megabyte per second from megabyte, big B. I would say that's pretty good if you're sustaining that. Okay, but like I said before, I have I think mine's actually 250 right now, because that's what Time Warner's getting ready to roll out. I'm one of their beta testers. So 250 divided by 8, I'm capable of 31.25 megabytes per second. How often do you think I'm getting served that kind of speed? Extremely rarely, right? Every now and then, once in a blue moon, maybe if I'm setting up World of Warcraft on a new machine or something like that, I'm downloading the actual client. That isn't, that's not something that a zillion people are hitting at once. Maybe I can start pulling 18 or 19 megabytes per second. But generally speaking, not 31. So does that mean I'm wasting my money? Is it just the human way? Faster is better. I always wondered why, like sports cars, like, this thing can go 0 to 100 in 2.1 seconds. Well, the speed limit is 35 in my neighborhood.
You're never gonna really use it now.
Well, a lot of people do, but they shouldn't. You shouldn't go 100, period, let alone in a residential neighborhood. But there's some people. But, punchline is as well, if you need it, you don't. So why get the super fast, crazy internet? This summer, when AT&T rolls out their gigabit internet in downtown Milwaukee, why should anybody get that?
Maybe the same idea as a frame per second you talked about before.
1024 divided by 8 is 128 megabytes per second. Okay, so tell me about this frames per second thing.
Same idea. So it's like when there is a lot of pressure, like there is a lot of people on the network, you will be able to get to the minimum acceptable speed that you want.
Okay, so it's less about a single application. I mean, our world today runs off the internet, correct? I mean, how many of you on a given night in your apartment or your dorm or wherever might be watching Netflix on a TV while playing a video game, while doing 3 or 4 other internet necessary things, right? When you add all those things up, I mean, at my house, my wife might be watching Netflix in one room. And she's watching it in 4K. I might be watching 4K Netflix in another room, plus whatever browsing and stuff we're doing. So that starts adding up, right? So if you have enough of a pool of download bandwidth to support all the things you're doing in the house, especially when you get these larger families that have, there's 6 or 7 people in the household, whether it's, parents and kids or just a bunch of roommates, whatever it is, having that bigger bandwidth pool is helpful, right? So that's kind of where the rationale comes from. Now, something he mentioned, though, is if you're, a lot of us, especially as students, we're going to be on a budget, right? So, yeah, they offer 200 megabits per second, but I want the budget pleaser. I want the guy that's $14 a month. Okay, that one right there. I mean, I want that one, but I want to pay for that one. That's what we want to do. So, does that mean that you can't watch Netflix? So now you're dealing with a 3 megabit per second connection or something like that. Now Netflix might go in and they might say that at least their default settings might limit what you can stream. They might not let you stream at 1080p. Definitely wouldn't let you stream at 4K. You possibly could override that. But worst case scenario, it's just going to take you a little bit longer for your show to start, right? And that's how Netflix works. Netflix buffers it. So, on my internet connection, when I go to watch Netflix, I hit play, it comes on seemingly instantly because it buffers the first 5 minutes in no time whatsoever. And then by the time I hit to 5 minutes, it's got the next 30. So it's, everything's fine. Well, if you got a slower internet connection, maybe you got to wait 30 or 40 seconds for your show to start. Then you're happy. Then it's good. It's going to be the same show. It just took a little bit more time for it to catch up. So I asked the question, what is good internet? And he said, well, it depends on what you're doing. Now, a little bit ago, you asked me about ping, about latency. So if you're a gamer, do you care more about download speed or do you care more about latency? By a lot. Okay? I mean, think about it. With these real-time games, first-person shooters, and you're pretty reliant on knowing where all your opponents are and your allies as well on the screen often, right? You want real time, or I call it relative real time. You're not getting pure real time, but it should be pretty close to real time. Does that probably tell you you're not sending graphics and stuff across the network? You're sending little tiny packets of XYZ coordinates, right? Where they are on the map. Little tiny things, similar to what it takes to type in google.com. Okay? You're not uploading your whole avatar on the screen and all the other stuff that's going on. So the amount of bandwidth you use for most video games is extremely small. Now, some online games, especially when you sometimes you'll notice when you go to like a new area, there's like a loading screen, right? As it's downloading maybe updated textures or downloading the randomized map or something like that. Downloading initial information that isn't part of the real-time gameplay. That's a little bit more bandwidth intensive. So sometimes you'll see some players are in the game a little quicker than some other players, that kind of stuff. But that's kind of before the action starts, right? You kind of wait till everybody's in the game before everybody starts running around and relying on real time. So what's good internet in there? Well, you'd like not to be the last person into the game. Okay, you want to be the person with the 5-second load screen instead of the 30-second load screen. What you really care about is the latency once you're in the game. And latency should not change based on the speed of your internet. Okay, so somebody with a 24 megabit per second connection should have, from the same provider, should have, certainly in my neighborhood at least, should have pretty similar latency to what I would have, even though I have a faster download speed. Make some sense? All right, so, and I kind of started this conversation around the idea of demystifying, kind of consumers being lied to. Because this is one of these things that gets thrown around. Somebody says, oh, we got 50 meg internet, and most consumers, even though they don't necessarily connect the dots to this level where they don't necessarily know the difference between a megabit and a megabyte, now we all do. We realize that's a substantial difference, right? But when somebody just says it to you, especially if they leave the B's off, right? Like, oh, yeah, it's 50 meg. He says it leaves room for interpretation. I promise that 100% of internet speeds are advertised as bits. Why do you think my internet provider advertises as 250 megabit instead of 31.25 megabytes? 250 is bigger number. Yeah. Huh? Even though megabytes is a bigger number, we know as technology folks, because we've seen this chart, the number 250 is a larger number than 31.25. It looks more impressive at a glance, even though we know it's a different measurement. It's like the difference between, like teaspoons to like gallons or quarts or something like that. Okay, we know that gallons are big. That's common knowledge, right? So if somebody says add 16 teaspoons to something as opposed to 1 gallon to something, because humans have we have a concept of the difference between a teaspoon and a gallon. We know that 1 gallon is a lot more than 16 teaspoons, right? But most people don't necessarily know that megabits and megabytes are even different things. Might just be the way they're saying it. Okay, so 250 looks more impressive than 31. That's why they say things like that. Things aren't as bad as it used to be at places like Best Buy. I remember way back, especially when hard drives started getting kind of, a little bit bigger in size, kind of in the days of the 1 gigabyte hard drive, probably before most of your times. Not terabyte, 1 gigabyte hard drive. When you went into Best Buy, they would advertise that in terms of the number of bits. I mean, they went to the extreme side of it, right? Okay, so if I go from gigabytes, this guy down here, to bits, I mean, you're able to claim billions of bits. And they wouldn't just say, 3.2 billion bits. They put out all the numbers. It's a big hard drive. Well, people don't know bits, computer stuff. Big number means better, right? Similarly to our, processor speeds, gigahertz versus megahertz versus, hertz. You have situations like that. So, I think especially in technology, we all obviously know that, places that are selling you stuff want you to buy the stuff, right? And technology is one of those things that a lot of folks aren't necessarily fluent in. I mean, all of us sitting in this room are supposed to be on that, that higher tier of the tech people, right? I mean, some of you have higher interest than maybe others, but, compared to maybe the common person who walks into Best Buy, we probably represent something above average. Yet, a majority of us didn't really have a feel for the size of these different things. Make sense? Okay, so, you figure that if they can take advantage of you, they can take advantage of anybody. All right, so we're out at 55, correct? Okay. So we were talking about conversion stuff, and we were talking about the size of memory and why we use larger bases. So
You said K is for what byte?
kilobytes,
Okay.
kilobytes. But I wrote them all with uppercase K, M, G over here. That part is less important. It's the B. Big B's mean bytes. Little B's mean bits. All right. So pretty often you'll see an internet connection advertised like that with a big M, but the little B, megabit per second.
I'll take the bytes.
Well, you take them, but that's not what they're selling you. Okay. And if a place ever advertises as megabytes, well, I say ever. Anytime soon, if they're advertising it in megabytes, they're either stupid. So if it's like a relatively small megabyte number, then that's just bad marketing. Honest marketing, but bad marketing. Otherwise, if they're saying something is like 250 megabytes, then they're lying to you. You know, it's just even 1 gigabit is not. Is only 128 megabytes. And we even see this in TV shows, and a lot of times, and this is one of the things I watch Big Bang Theory pretty often, and they have experts on the show, I'm sure, to do the research. It always ticks me off when they like get facts wrong. So many of us have seen in movies when they talk about having an internet connection, a T1 connection. You ever seen? You never seen a T1 connection referenced in a movie?
No.
None of you? Really? Okay, well, that sounds impressive, though, right? Have a T1 connection directly to your house. Even today, a T1 connection is probably, I don't know, $3,000 or $4,000 per month. Per month. For a dedicated T1 connection right to your house.
It's so special.
Well, I don't know. Just so right off the bat, if I say, hey, would you rather have whatever your internet is today, your $50 a month internet, would you rather have a T1 connection? Most of us would say we'd rather have a T1 connection.
I don't know what the T1 connection is.
It sounds impressive, right? I'm not going to tell you. You might have buyer's remorse, but right now you got to decide. I'm going to give it to you for free. Do you want the $60 internet or you want the $3,000 internet? Which do you want?
$60.
You want the $60 internet instead of $3,000?
I can't afford $3,000.
No, I'm going to give it to you for free. It's not going to cost you a dime. It's a gift. You want $3,000 internet, you want $60 internet.
I'm so sick with the $6. I don't know what's so special about $3,000.
Well, you just know it's more expensive.
It doesn't mean it's always better.
Well, it might be
Yeah,
true.
like, even if it's not better, you can sell it to someone else.
So this is most of you aren't getting the joke because you haven't seen it in the movies, but a T1 connection is actually 1.44 megabits per second. It is synchronous, so it goes both ways at that speed. And it's dedicated, but this would, by today's standards, is extremely slow. Extremely slow. It's pretty secure, so places that still do this today, it's for dedicated, secure lines and that kind of stuff. A lot of times running alarm systems and that kind of crap. All right. All right. Questions, comments, concerns, bribes. Okay, well, since it's Super Bowl weekend, I'll give you the weekend off for homework, and I will see everybody on Monday.